assistant professor at the University of Memphis. Today, I present my work of easy adaptation to mitigate gender bias in multilingual text classification. Fairness is a challenge to build trust text classifiers. Extensive methods have proposed new studies to reduce the bias in text classifiers. However, there are limited studies have been evaluated under multilingual settings. We particularly focus on the group fairness, which are document classifiers are defined as bias if the classifier performed better for documents of some groups than for documents of the other groups. Particularly, we actually focus on the gender bias, namely male versus the females. To reduce the bias of the text classifier, we actually propose a framework called Easy Adaptation Framework. It does not restrict to the neural models, but also incorporates the non-neural models. It splits into the two steps, training and testing. To construct the non-biased representations of documents, we actually deploy a techniques using the feature augmentations from Dr. Domain, frustratingly easy domain adaptation. It creates two types of the features, domain independent, general features, domain dependent features, which are the female and the male features. So here how it works. During the training, if the document's author is a female, we actually represent the document representation as those are three sets of the features. General features, female features, and zeros for male features. For the male, we actually create a similar way. General features, zero for the female features, and female features. During the testing purposes, we only fit the general features to the model. This creates two benefits. The first, the general feature does not rely on any domains of features. Second, such a feature representation does not require us to know the author's profile of the documents. To verify our methods, we evaluate our methods on two multilingual data sets, hate speech and written predictions. Cover 7 different languages, English, Italian, Portuguese, Spanish, and so on. We evaluate our approaches under two types of evaluation methods, regular and fair aware. For the regular, particularly I want to point out is F1 micro does have a less impact from the imbalanced class. And for the fair evaluations, we use the sum of the FPED and FNED, which means equity difference of the false positive or negative rates. We evaluate our methods and compare our methods with the different baselines that covering the both neural-based approaches and non-neural classifiers. We present the performance scores on this table. A lower fire score is better. The delta R and F are the improvements over the regular and a fair baseline respectively. Negative delta scores over the field indicate a percentage of mitigating the biases, and lower scores means more biased mitigations. So here's our three takeaways. Fair aware methods reduce gender biases under multilingual settings. Will not generally improve the accuracy. And we found that translating the gender sensitive tokens from English to the other languages can be effective for multilingual settings. We demonstrate our adaptation methods is easy, straightforward, and effective. To find out more detailed information, please go to my GitHub pages. And thank you so much for listening.
Hello everyone, I'm Xiao Liu from Peking University. Today I'm presenting our paper of leveraging causal inference in legal text analysis. Let me first introduce some basic knowledge of causal inference. Causal inference is the process of exploring how changes on variable t affect another variable y. Here t is called treatment and y is called outcome. For example, if we want to analyze the changes in health status of a headache patient related to taking pills, whether taking pills or not is the treatment, and the follow-up health status is the outcome. Two types of questions are typically related to causality. The first type, called causal discovery, focuses on whether there is causal relationship between a set of variables. It takes observations of variables as input and their relations as output, usually in the form of a causal graph. When two variables t and y are causally related, the second type of questions cares about the causal strength between them. It wants to quantify how much would y change if we change the value of t. Most research in causal inference focus on structured data. Take the famous research question, how smoking causes lung cancer, as an example. This kind of studies are conducted on electronic health records, which are in the form of tables and databases. Some recent works attempt to integrate text into causal inference, but they mainly treat the text as a whole. For example, Yao and others investigated how the complaints from consumers affect the company's responses. They regard the entire text of complaint as a treatment, without looking into different aspects of the text. Discovering causal relationship inside text is also beneficial for scenarios involving reading comprehensive text and making decisions accordingly. In this paper, we focus on mining causal relations inside text without much human involvement.